Now let's talk about capacitors. The capacitor is a component which has the ability or capacity to store energy in form of electrical charges, producing a potential difference that is static voltage across its plates, much like a small rechargeable battery. In its basic form, a capacitor consists of two or more parallel conductive metal plates which are not connected or touching each other but are electrically separated either by air or by some form of good insulating material such as wax paper, mica, ceramic, plastic or some form of liquid gel as used as electrolytic capacitors. The insulating layer between a capacitor plate is commonly called as dielectric. Due to the insulating layer, DC current cannot flow through the capacitor as it blocks its allowing instead of voltage to be present across the plates in form of the electrical charges. Imagine a water tank constantly filled by a water pump, where the tap connected at house supplies a constant water flow. Though the pump is turned off, as the tank has enough water in it, it allows a constant water flow through the tap. Hence, tank acts as a storage or a capacitor. An electrolytic capacitor is a polarized capacitor whose anode or positive plate is made up of metal that forms an insulating oxide layers. These oxide layers acts as a dielectric of the capacitor. A solid, liquid or a gel electrolyte covers the surface of the oxide layer, serving as a cathode or a negative plate of the capacitor. Due to their very thin dielectric oxide layer and enlarged anode surface, electrolytic capacitors have a much higher capacitance voltage produced per unit volume. What is dielectric? A dielectric is an electrical insulator that can be polarized by an applied electric field. When dielectrics are placed in an electric field, practically no current flows in them because, unlike metals, they have no loosely bound or free electrons that may drift through the material. Instead, electric polarization occurs. The positive charge within the dielectric are displaced magnetically in the direction opposite to the electric charge. This slight separation of the charge or the polarization reduces the electric field within the dielectric.